All right, this is for physics CP, debriefing on this particular homework assignment. Title was Centripetal Force and Newton's Universal Law of Gravitation, ULOG. The formula for centripetal acceleration, A sub c, is equal to v squared divided by the radius. Another way of writing it is 4 pi squared times the radius divided by the period squared. Centripetal force is mass times the centripetal acceleration. And Newton's law of universal gravitation says the force of gravitational attraction between any two objects is the product of capital G times the mass of the first object times the mass of the second object divided by the distance from the center of one object to the center of the second object squared. So let's go and apply it right now to these homework problems. Number 1. A stone is moving in a circle at a speed of 12.5 meters per second in a radius of 2.15 meters. What is the centripetal acceleration of the stone? Well, A sub c is equal to v squared divided by r. In this case, 12.5 meters per second quantity squared divided by 2.15 meters is going to be the answer. So, powering up the calculator, 12.5 squared divided by 2.15, enter. And you can't read it, but the calculator says 72.7. So 72.7 meters per second squared is the answer to number 1, the centripetal acceleration. Number 2, a machine nut is moving in a circle with a centripetal acceleration of 32.6 meters per second squared, while it is moving at a speed of 20.5 centimeters per second. What is the radius? Well, first of all, I know that 100 centimeters is equal to 1 meter by definition. So a speed of 20.5 centimeters per second is really a speed of 0.205 meters per second. I'm going to use the centripetal acceleration formula of A sub c is equal to v squared divided by r. And in this case, I'm going to rearrange the equation to solve for r. So multiplying both sides by r, dividing both sides by the centripetal acceleration, I have r is equal to v squared divided by the acceleration. The numbers that I'm going to plug in are 0.205 meters per second squared divided by 32.6 meters per second squared. So 0.205 squared divided by 32.6 is a very small radius. In meters, it says 0.001. Now that's only one significant digit, so don't just write that. Do this to 3 sig figs, where it says 0.00129 meters. Now, if you want to express that in centimeters, move the decimal point to the right 2 places, and this becomes 0.129 centimeters. If you want to convert that to millimeters, then you move the decimal one more place to the right, and it'd be 1.29 millimeters. All right, so that answers number 2. Number 3. Actually, I'm trying to think for a moment. Does this seem like a reasonable number? Yeah, because it's not moving very fast. So it's got to be a small radius. All right, number 3. A brick has a mass of 2.10 kilograms. It is moving in a circle with a speed of 3.45 meters per second. The circle has a radius of 76.9 centimeters. What is the centripetal force on the brick? Well, again, if the radius is 76.9 centimeters and there's 100 centimeters in a meter, then the radius really is 0.769 meters. To calculate the centripetal force, I would multiply the mass by the centripetal acceleration. the centripetal acceleration would be v squared divided by the radius of the circle. So the numbers I'm going to plug in are 2.10 kilograms for the mass times 3.45 meters per second for the velocity, then square that, then divide that by 0.769 meters. So 2.1 times 3.45 squared divided by 0.769, enter, and it says 32.5. 32.5 newtons would be the centripetal force necessary to make this brick continue to move in a circle instead of going off at a tangent. And by the way, if I make any mistakes during this video recording, some student better get my attention. Otherwise, it's going to get posted online with the mistake, as have previous videos. Number 4, an 8.10 kilogram bowling ball is located 68.0 centimeters from a 10.2 kilogram bowling ball. What is the force of gravitational attraction between them? Well, if the distance is 68.0 centimeters, and I know that 100 centimeters is 1 meter, then this distance really is 0.680 meters. And yes, that last zero is actually a significant digit. So these are 3 sig figs, 3 sig figs, 3 sig figs. Calculate the answer to 3 sig figs. Newton's law of universal gravitation says it is an attractive force equal to the universal gravitational constant times mass 1 times mass 2 divided by the distance from the center of mass 1 to mass 2 squared. So on my calculator, I would go alpha g, because I've stored that in my memory, times 8.10 times 10.2 divided by 0.680, quantity squared, enter, and it shows a teeny tiny number. It says it is an attractive force, minus sign for that, of 1.19 times 10 to the negative 8th power newtons. Number 5, the magnitude of the force of gravitational attraction between a 55,100 kilogram ship and a 105,200 kilogram jetty is 3.25 nanonewtons. Recall that a nano is 10 to the negative 9th power. What is the distance from the center of the ship to the center of the jetty? So I have a ship, I guess, and I have a jetty, which I can't even draw. Yeah, right. And the mass of the ship is 55,100 kilograms. The mass of the jetty, which is like part of a port, is 105,200 kilograms. And the distance from the center of one to the center of the other is unknown. That's what we're going to try to solve for. What we do know is that the magnitude of the force of gravitational attraction is 3.25 times 10 to the negative 9th power newtons. And so for this problem, we're going to use Newton's law of universal gravitation, G m1 m2 over r squared. The minus sign just means it's attractive. We're solving for r this time. So I would first multiply both sides by r squared. Then I would divide both sides by the force of gravity. That will isolate the r squared on one side of the equal sign. And then finally, take the square root of all that. So r of both sides. So r is equal to the square root of G, M1, M2, divided by the magnitude of the force of gravity between them. You're not going to be taking the square root of a negative number in this part of the course. So the numbers you plug in are square root of G times 55,100 times 105,200 divided by 3.25 times 10 to the negative ninth. I'm sorry, the minus sign didn't get written. Negative ninth, that will be a big difference, won't it? Times 10 to the negative ninth. Enter. The distance from the center of the ship to the center of the jetty is 10,900 meters to 3 sig figs, which would be 10.9 kilometers. And then if you're curious, what is that? So 10, so divided by 8 times 5, approximately a little less than 7 miles. Okay, a little under 7 miles. And no, I wouldn't expect you to convert the answer to miles. So this concludes the debrief on this review sheet.